Oh, and let me see the. We have other tasks and just set number 5. Okay, and I think that we have. So the last thing we have done was task number 4. Am I correct? Concatenation.
Yes.
Okay, so let's see task number 5, 6, and 7. So okay, let's start from the task number 5. Okay, we have one volunteer. So please, Mr. Władysław, if you can show us present the solution. So now, of course, now we can use these functions like concatenation and the previous ones in the maybe previous ones, which is not a good idea. But we can use concatenation here because we have already have that procedure. Okay. So can you describe what this section do here?
Okay, so we start from the first symbol. Actually, we have 2 additional registers. RTMP contains string from Rx except last symbol for each iteration. Just we decrease it by 1 each time. And rlast is last symbol from Rx from which we read. So we basically start by checking y by 1 and adding this symbol to rlast and deleting the symbol to Rx. To check if it is the last symbol, we are jumping to ncheck. So if Rx still has any symbols there, we jump back. We jump to n. And what b, and what and what adds rlast to our temporary register, because we need to store each of them except the last one. In case if sorry, I lost word. Okay, in case of it was the last symbol from Rx, we are jumping to nc. It's like stands for ncopy, for example. If it was rlast was 0, we add to our solution 0, and if it was 1, we add 1. So like this it works. Then we jump back to ncc and copy continue, for example, and copy whole string except the last symbol from RTMP to Rx. So actually we are copying a string from Rx except last symbol. So it's what's stored in temporary. Then we clear temporary, delete last symbol, and again check if Rx still has something or not. If it has something, we jump back to start of the program. If not, we continue and it's terminate the program.
Okay, let me check once more. So we check the first symbol of Rx and jump here. And
sorry.
rlast is the last, the current last symbol of Rx, yeah?
Yes.
Okay, so it's 0 or 1, and we jump to uncheck. In rcheck, we check if the string if Rx is empty or no. If it is not empty, then we jump to mode. We check our last and case if empty Rx, it's not here. Ah, here.
Yeah, I think we can have a case when our last is empty, so actually not, but let's just for checking.
Okay, so if it is not empty, then we check if it is 0 or
For our last, you mean?
and then we add the symbol from rlast to r10. So r10 is the solution. I don't know. What is?
Yes, according to just task, yes, it must be the solution. Okay, and in what I have redundant this jump in CB. I thought it's for our, it's not needed, but it can be there, but it won't be executed.
And when we jump to this and add this S0
and add S0 from NC. I think I can use here concatenation, but I forgot about it. So instead of this jumping.
Something is wrong with my connection. Sorry.
Can you hear me now?
Better. Okay, so the idea is the following: we take the last we take the last symbol. We take the first symbol of Rx and we write it to rlast. Yeah.
Yes. We iterate through Rx till the last symbol. And store in RTMP at final step. I mean, whole string from Rx for current stage, except the last symbol.
And but is it in reverse order or no?
For RTMP? For RTMP, yes. No. It's in original order.
It's on original orders. Okay, wait a moment.
Reverse order. I'm creating reverse order, just adding rlast to RZ.
RZ. Okay. Okay, so once more, we take we go through this register Rx from the first symbol to the last one. We delete the first symbol and write it in rlast.
Yes.
And we append it to RZ.
No. We are appending to RZ only at the very end when we reach the last symbol of Rx.
Okay.
We append our last to RTMP in order to save whole string except the last symbol. Just to iterate one more time until RTMP is not empty. So it's great, basically like this.
Okay, so for example, our string Rx has I don't know 3 symbols, yeah.
Mm-hmm.
So what is in this? Maybe we'll do some simulation. So what is in the? Let's say that our string is I don't know x1, x2, and x3. Okay.
Okay.
So what is after? What is going on in rlast and rtemp and rv after every step?
Okay, so let me write x1, x2, x3, right? X1, x2, x3. So we check x1 if it's 0 or 1.
Yeah.
Write to our last x1. Check if delete the symbol from Rx. Check if Rx still has anything. If yes, we jump, and it has because it's still we have x2. We write our last to RTMP. X1
so here we jump to and what?
And what? Yes, and n at 0.
Yeah, and in this section n at 0 or n at 1 we add. So now rtemp is also x1.
Yes. Next, we jump again to the beginning of our program. Again, check x2. Delete x2 from Rx. Check if still we have x3. So we okay. Also, we removed from our last x1 and write x2 to it. Now we are jumping to and what, checking that it contains x still contains x3. Because of that, we are writing x2 to RTMP also. So we are not cleaning but added. So we have x1, x2 at this step in RTMP, and our last is equal to x2. Checking x3. We are jumping now to again checking. We first we delete our last, anything what is stored. Write x3 to our last. Jumping to and check. We see that Rx is now empty. It doesn't contain anything. So we are jumping to NC.
So so in our last it is x3 and in rtemp it is x1, x2.
Yes. We add x3 to RZ. Jump back to NCC. And now since Rx is empty, we just copy everything from RTMP to Rx. Now our Rx is equal to x1, x2.
Oh, so after this this whole part of the program, we have copied the last symbol from Rx into RZ, and in Rx we have our string in Rx is without the last symbol.
Yes.
Okay.
And we jump back again to the start of our program and just repeat it for x1, x2.
Okay, so the one thing is missing, because at the end of the program, Rx is empty, and it should be the same string as it was in the beginning.
Ah, really? Okay, yeah. I didn't know.
So you have to copy it somewhere first, and then copy it back to Rx or something like this. Yeah.
we can add additional register like our TMP RX, for example, and just add it back to our copy back to RX and clean RX TMP RX. So something like that.
I suggest that before you change this n, before this n, you put here you change every Rx into something like Rx prime, okay?
Mm-hmm.
And in the first line before the n, so you put this n above and or maybe a 0 or something like it start and copy and use copy Rx to Rx prime, and this is it.
Okay, I will send it just right now. Okay, let's. I hope I won't miss any.
So maybe this line should also be this first line now should be named, for example, n prime, and in the before the last continue, we will have jumped to n prime above, n prime above.
May I just leave it like n and start from n start? Just
okay.
It will be Rx prime.
Okay, so this is it. The idea is good.
Okay, Rx.
I know that it can be done. I don't know if easier, but it can be also done using this concatenation from the previous task.
Yes. I missed it. Sorry, I just didn't check it. So I just.
Okay. So this will be a thumb and a plus. But if somebody has this solution using concatenation, then please present the solution. You can present also the solution.
So to send, do I need to send the corrected version?
Yeah, please send the correct version.
Yes.
So this is the thumb and a plus. So plus and thumb in a moment. So my question is, can anybody solve this task using concatenation? I think the code is then shorter. Okay, so in the meantime, maybe somebody will volunteer. Let's see the task number 6. So it is addition. Now, again, I have some problems with my connection. Do you hear me?
Yes.
I have some problems with internet.
Okay, I hope. No, it's okay.
Okay, I see something. And okay, so Rx is unchanged. So this is a thumb and okay.
By the way, may I ask you about one thing, because I can't see. But could you please one more time make screenshot, or not screenshot, but photo of? I think it was number. Okay.
You need another photo of something from the lecture or from the tutorial?
Okay. Sorry. I had problems with internet too. I think it was photo number 35 or something like from previous lecture. It's you can check it. It's like quite blurry, let's say.
Okay, so please write me a message about it on maybe on the general channel, and I will upload any photo. Okay?
Okay. I will. Thank you.
Okay. So I'm writing here a comment that Nation. Should be short. Okay, so if somebody solves it shorter, then please present. And we have one volunteer for addition, and this is Mr. Janusz.
Yes, it's me. So let me upload.
Oh, sorry, maybe Mr. Vladislav, I have one more thing. Do you hear me?
I'm afraid he left.
Oh, okay.
Yeah, probably his connection wasn't okay.
Okay. Yeah, he's awesome. He said something about. Okay, so let's see that.
Okay, do you see the solution? Did it upload?
No.
Okay.
Okay, now I think I see something. Yeah.
Okay.
Okay, so please explain what's going on.
Okay, so basically, as usually when we compute addition by hand, we start from the right-hand side and proceed to the left-hand side. So I start with flipping the contents of registers Rx and Ry, and the registers Ra and Rb will be the reversed version of the numbers we are adding together. RC will play a role of a flag, which will say whether in the previous computation we obtained a number higher than 1, namely we obtain like 2 that should proceed to the next digit. And RD is the result of a sum, but in the reverse order. So so jumping to the code, in the line starting from n, we just reverse the two numbers and set the flag to 0 and jump to ns. So and then we have like 6 cases in total. When we are adding 0 0 and flag is 0, when we add 0 0 and flag is 1, when we add 0 1 or 1 0 with flag 0, when we add 0 1 or 1 0 with flag 1, and we have 1 1 with flag 0 and 1 1 with flag 1. So basically, this the first subscript indicates the first number. The second digit of a subscript represents the second number that is added, and the third one represents the value of a flag. So, for example, if we add digits 0 plus 0 and flag is 0, then we go to n0, then we jump to n00 and jump to n00. It yields for 0 that is being added to RD, and nothing changes with that flag. So we delete the first digit from RA and RB and proceed again.
Okay.
And oh, so one more thing, that when we add 0 plus 1 and 1 plus 0 is the same case, so actually we have these two cases less, as I used the 0, 1 case. And after this addition, when we run out of numbers in
Sorry. So I understand N00 and N0, N000, N010. Okay. Now let's see if we have what's going on in this N001. Okay, so we add 1 and we delete LC. And okay, so now we want LC to be 0. Okay, this is correct. Okay, N011. So we want to have 0 in RD. Okay. Okay, and we want to have 0 in RC. Correct. Here we have 110. So the result is 0, and we want to have in N110 in the third line, line number 3. Shouldn't it be add 1 to RC?
Yes, it should be.
Okay.
Again, 110. Yeah, it should be 0 there. Sorry.
And in the next one, the same, yeah?
Yeah, exactly.
Okay.
Yeah, when I was rewriting, I made a mistake. Yeah, of course, there should be ones. And so after this, I also check whether there is still. So when we run out of digits, I also check whether there is still flag set to 1. Then we need to append one more 1, and then I return the reverse order to RZ. However, this now I just noticed it. This program has one issue, that
it only works.
Yeah, the digits are the numbers are of the same length.
Yeah. So we have to correct it. Yeah. Okay. So please change the zeros into ones, and we have to add some part that in the case that we have run out of one's number, and the other one still has some digits.
So I think that at the beginning, just after we reverse, after we flip the numbers, we can up zeros. I think like we can append as many zeros to the shorter number so that the length matches the other one, and then the algorithm works.
We can solve it this way. Yeah, correct.
Yes, but then we need again some way of some new line names, and then like iterate and do it like even both ways, in case RA is larger and in case RB is larger. Okay, so maybe it is enough if I just write a comment explaining how it should work, because I'm afraid that writing this part of the algorithm can take some time, and but it's not hard. Like the main part is already done.
So my idea is to write a comment that it works only for. So please correct these 2 zeros into ones, and
yes.
I will write a comment that it works only for the numbers of the same length, and you will correct this I don't know, maybe not now, and upload the corrected version. Okay.
Okay.
So please, we have to. we have to add some part of the program that deals with the situation such that the numbers are of different range.
Mm-hmm. Okay, so for now I uploading the corrected version with this flag register, and I don't know, maybe later today or maybe just before the next classes, I will add this new section that adds these extra zeros.
Okay, so okay, but this action was on of the line. We will see, or maybe we will see the full version soon. Correct?
Yes.
Okay. Yeah, I told you that this addition is the hardest one of these tasks. So okay, so maybe in the meantime we'll see task number 7. It is multiplication. So we have also one volunteer. This is Mr. Philip. So Mr. Philip, can you show us the multiplication? So now we will use a good fact about multiplication in binary, because if we multiply something by in a binary system, so digit by digit, we always multiply by 0 or by 1 something. So multiplying by 0 results in 0, and multiplying in 1 results in the same number as was before. So it is easy to multiply in binary. Yeah, but I think that I'm afraid that okay, Mr. Phil, can you hear me? Okay, we have something. Okay, so we start with 0 and we reverse Rx. Okay, and we go through this RTX one by one. Okay, 0. We just append 0.
Hello?
So could you please explain what's going on?
Sorry. I was explaining and then I worked out that. Okay, so first I append 0 to initializer z at 0, not to have it empty after the program exits. I use RTX as a temporary X, which is reversed because I go from the smallest digits to the largest digits. And then, okay, the first digit is 0. I go to, I have a variable RL, which is basically the length of current digits. So what is the current digit, how far it is, basically. And if it's 0.
So am I correct? After each step, we will add 1 0 to this RL.
Exactly.
Okay.
and if it's 0, we delete this digit from temporary x and then go back to the ns, which is start. But if it's 1, we initialize temporary length and a temporary y, and then if it's basically the RTL just stores a bunch of zeros. So we go to n RTL 0 and delete those zeros one by one up till and while we do it, add zeros at the end of RTY. And as long as we do it, we'll add zeros by zeros to the temporary y, which is basically just this y multiplied by as many 2's as the digits we passed already. And then we just sum the temporary y to the z, and again delete there should be t, delete rtx, not x, and add 0 again and go back and do this as long as we have digits in RTX.
Okay, wait a moment. So okay, so we so we add zeros to R, T, Y as long as there are zeros in. So we append the number of zeros in RTR to RTY.
Yes,
Yeah?
exactly.
And then in N RTR we have no more zeros. Then we go to this. We add Z, correct, and we delete RTX.
Yes, exactly. That's the mistype. I will just send it over again in a second. Yeah. But then
Okay. So I have two remarks, maybe 3 remarks. First remark is that we want to have the last instruction. We want to have discontinue. So maybe instead of discontinue here in the 5th line, it should be jumped to somewhere on the continue in the end. Then we have to correct this delete Rx into delete RTX, and please write maybe in the comment that these RTX and so on are unused registers and so on.
Okay.
And okay, and maybe something like because I don't know if this new unused registers should be cleared before the last continue.
Okay, I will. Okay, so they will be cleared. Okay, so I will send in a second the.
Okay, the solution is correct.
Okay, thank you.
Okay, so I'm waiting for it. Okay, so in a moment we will have a correct solution. So my question is the following. Because I think I can write a shorter solution to this reverse function. So shall I leave it to you, or shall I present my solution, which should be shorter?
You can leave it to us.
Could you please repeat, because I didn't hear?
Sorry. You can leave it to us. We can do it. I think. I think I know how to do it.
Okay. So maybe because we have only 1 tutorial, so maybe it is a good idea that please, if you have some solution, then you can maybe not post it here, but show me in a private conversation, and if I accept it, then you can upload it in not on the next tutorials, but during the week. Okay.
Okay.
So if you have a solution, then you can show it to me in a private conversation, and if it is correct, then I will ask you to upload it, and we won't wait to the next tutorials.
Okay.
Okay, so now let's wait a moment for Mr. Philip. Okay. Okay, it's there. John, clear. Okay, correct. So a thumb and a plus.
Thank you.
Okay, so we have two more tasks. So we have one task. Where is it? So we have to correct task number 6, so addition, and we have Mr. Janusz working on that, and we have one more task, task number 5, so reversing other version, yeah, shorter version. So I don't know if we leave it as a homework or we work on it now.
Well, when it comes to the correction of 5.6, I'd rather do it later during the week,
Yeah,
because it might be hard for me to focus so quickly.
Because I know that this is the hardest one.
Yeah, this is a bit tough. Well, like I know how to do it, but needs some more time for it.
Yeah, the idea is easy, but the details are difficult.
Yeah, yes.
Okay, so task number 5. So my question is, do we leave it as a homework or do we work on this shorter version now?
I think we can call it a day and present it next week.
Okay. Okay. So my idea is not present it this next week, but if you have some solution, then please show it to me in a private conversation, and then we will upload it before the next tutorials. Okay.
All right.
Okay. And there was some question about one photo. So please, if you could write me what is this photo? What is the number of this file? Okay, so maybe I will write here in the Teams. Come on, something is wrong with the internet today, and not only with my internet. Okay, so I will only write here that if you have a shorter version, then please show it to me on private. Oh, okay. Okay. So we have 2 more tasks to correct, and thank you for your attention, and see you next week. Okay.
Thank you.
Thank you. Goodbye.
Bye.